Thank you so much, Dr. Otieno, for that great introduction. And thank you also for the invitation to come here to the MERC conference this year and talk with you about advanced manufacturing, harnessing data to lead the transformation. It's a really important topic. Any of you involved in engineering or manufacturing will be familiar with Dr. Williams Deming, who is the grandfather of reliability and quality management. He invented the theory that all failures are rooted in some sort of deficiency that was created by an error in process or people. And he would be delighted with the types of solutions and tools that we have available today in this holistic world of connected web, interwoven by technology that's constantly sensing the health of various nodes of its network and auto-correcting for deficiencies. He developed the theories that these deficiencies become the root of all failures, and he believed in beginning with the end in mind. And so he would always open his meetings with the statement, "Why are we here?" And I think most of the time he would have said that he was there to make a better world. And I think that's why we're all here too, each of you at this conference, studying, working, continuing to make a better world. Of course, what making a better world means has a lot to do with individual and organizational perspectives. We need to do more than just produce and sell stuff efficiently. We live in a connected world in which everything, including manufacturing, depends on a healthy ecosystem, and that's the focus of the conference today. Also here to talk about data analytics, machine learning, and the industrial digitalization era, known as the Internet of Things, the IIoT. It can help us develop and implement smart manufacturing strategies and processes. When I think about what the future looks like in the world of advanced manufacturing, I think about the futuristic world depicted in the movie Avatar. It's the epic science fiction film. The movie's set in the year 2154, and humans have depleted the Earth's natural resources and are trying to colonize a fictional moon orbiting a planet in the Alpha Centauri star system. Avatar depicts a world of complex systems of interconnected resources and assets in which people, processes, and technology converge. And while there's plenty of poetic license in science fiction stories, manufacturers in today's Industry 4.0 ecosystem are using data analytics and artificial intelligence to create automated self-learning production processes now. The future is here. Manufacturers are lighting the way for what I call the fourth level of integration, in which we go beyond the outer limits of today's IIoT, outside the walls of our enterprises, further and further into larger and more tightly integrated supply chains until they fully emerge to create an avatar world of more fully interconnected devices, data, resource systems, and people. Right now, enterprises are using machine learning to analyze real-time data about everything from supply chains to operations. They're using technology to assess risk, to predict demand, and to engage with customers in ways never before imagined, completely transforming markets and aligning more closely to customers by designing systems that connect with what they need and want. Technology is giving us a more perfect awareness of our environment, informed by a full spectrum of sensors, from camera-based vision systems to voice and unstructured text. It's a multitude of connected sensors that are monitoring our equipment and checking the quality of our products. Digital technology is enabling us to connect assets in ways that we never knew before, to give us a better understanding of the entire ecosystem, the entire value chain, and how it interacts together. In this fourth level of integration, sensors are also monitoring the ability of the Earth to sustain this complex web of people, and assets. Remember, any system is constrained by its weakest link. The health and well-being of the planet is a foundational asset for every business. And the ability of the earth to supply the demand for natural resources has to be balanced with an eye towards sustainability. Else, one day we're going to be looking for our own new planet in the Alpha Centauri star system. We need to harness the power of machine learning and AI to go beyond automating production facilities. Technology has to make it better, has to make us better at what we do and how we do it. The challenge for manufacturers today is to understand how to integrate people, processes, and technology in order to improve efficiency and productivity. Two essential tools for this are machine learning and analytics. The promise of machine learning is being realized today in advanced manufacturing environments. We have machines that learn from experience thanks to powerful computer processing capabilities and the ability to store and move massive amounts of data from the edge to the cloud and back. Machine learning algorithms are routinely solving problems in advanced manufacturing environment. One example comes from the world of welding. Many discrete operations have welding processes as a means to fuse pieces together for durability and strength. But welding is expensive. It's a balance of the power investment with the strength of the weld that you're going for. And so manufacturers are constantly seeking the perfect balance of this investment for target quality metrics. Welding seams can become compromised, though, when air is introduced into the seam. This happens when a shielding gas is compromised for some reason. And when that starts to happen, when oxygen starts to enter the weld, sparks start to happen. Visual cameras can be trained on the welding point. AI algorithms can be trained to watch for changes in the image to identify these sparks when it happens and create a halting action on the weld, eliminating the bad seam to begin with, eliminating a lot of labor-intensive and expensive rework processes. And the example I'm describing here is not found in a science fiction movie. It's happening today. Accenture defines AI as a constellation of technologies, from machine learning to natural language processing, that allows machines to sense, comprehend, act, and learn. AI is no longer just nice to have, and it's not just for large manufacturers anymore. Wisconsin manufacturers of all sizes need to understand how they can benefit from these digitalization opportunities. Analytics is what turns unstructured data into useful business insights. Machine learning automates the processing and analysis of large volumes of data. And this facilitates the ability for manufacturers to optimize the use of the data and then benefit from processing this at the edge so much faster. Considerations that will go into the kinds of decisions that you will make about the types of hardware and software to use will be things related to latency and power requirements and applying those specifically to the applications they need, and a large challenge in a legacy equipment environment. You certainly don't want to introduce a new failure mode while you're trying to mitigate another. The power of analytics transforms massive amounts of data from sensing systems, devices, access points, into information that can be used for real-time decision making. Terabytes of data produced by machines and processes need to be captured in seconds. As much as 95% of the data that's being generated today is useless after about 3 seconds. The ability to parse that data at levels appropriate to the analysis is really critical for machine operation in a production environment. An example I'd like to highlight comes from ThyssenKrupp, which is part of the Wisconsin community. And the use case I'll describe here talks about a digital networking platform that they created to connect machinery in a very large network and to facilitate the communication between these devices. The goal is to make production processes transparent and increase quality, performance, and of course, automated more and more processes. At ThyssenKrupp, they chose to focus on a small part of their business to prove out the benefits of using analytics to improve yield in their metal cutting operation. As large sheets of metal are fed through the slitting machine, rollers press down from above to control the feed of the sheet through the knives. If the spring tension on one of the rollers becomes fractionally less than the other, the plate will start to twist as it goes through the cutting blade and it will ruin the batch. Sensing technology can measure these pressures more precisely than humans and can identify a microscopic change in tension and trigger an event that, for instance, might send a signal to a servo device to stop the machine before moving the plate, or send a signal to the operator to disengage the equipment. It's a relatively simple machine learning application that uses data from sensing technology to automate, and then they moved it out to scale. ThyssenKrupp implemented Toy Solution across their whole network, operating more than 300 metal cutting machines on it, slitting and cut to length lines for steel slabs and pipe, packaging lines, bandsaws, weights, measuring systems, high bay warehouses. And in addition, it integrated numerous cranes, forklifts, wheel loaders, and other vehicles in its network. And the advantages of doing all this work are really underscored when you take a look at the analytics. The benefits for a single plant that produces slit steel produced an annual production increase of more than 10,000 pounds, 10,000 tons. In other areas, the automation has reduced production line downtime by as much as 10%. That's a lot. Optimizing efficiency and improving productivity are really what plant managers dream about. But really, to implement a successful data analytics strategy, you have to start with a broader systems analysis, because really, it's not just one component of an interconnected technology solution, it's all of them together. That's the meaning of context. So you have to start with the end in mind. And if your goal is to make a process more efficient, make sure you have the process well defined. You need to understand every nuance of a process before it can be automated, because that's where your failures can occur. A key part of it is teaching the machine learning what data is important and how it relates to the whole system. It's that weighting factor as the machine learning algorithm moves from its initial design to deep learning phase. It's important to do a comprehensive risk analysis of your production environments and understand where your system constraints are. This entire process of strategizing and building an automated system is, of course, part of the people component in the people, processes, and technology equation. People are an important part of an industrial IoT system. Human brain power is required to teach the machines to think, and it's also required for gleaning business insights from the data being processed by machine learning systems. People are the architects of data analytics and machine learning systems, and we need to keep that in mind as we're building them. You've heard the cliche, garbage in, garbage out, and this is especially true with artificial intelligence and data analytics. So trust of data is a big issue for manufacturers right now. Putting technology to work requires the ongoing integration of people who will benefit from the machine learning insight and the control and automation opportunities that it provides. And remember, like AI is designed to enhance human analytic capabilities, not replace them fully. And while we're on the subject of people, one of the most significant challenges for advanced manufacturing right now is closing the skills gap. We need a workforce fluent in the language of AI and analytics, and that starts with developing training programs for students. But technology, as we know, does not stand still. To keep pace with change, manufacturers must ensure that their workers have access to continuing education opportunities. And this can range from in-house programs to workshops, seminars, all sorts of different delivery methods, and of course, academia. Workforce training requires public and private sector support to provide and develop technological literacy programs and to assure that they meet the most needy. And these are exactly the kinds of education programs that we are working on developing here at UWM at the Connected Systems Institute. Our sponsors help keep the lights on and pay our staff, but the true power of their collaboration is in the rich environment of advanced manufacturing tool sets that are not set up in an active manufacturing environment, but instead a research lab environment where all of the risk is taken away and it's in a place where learning and research can happen freely and unencumbered by risk. And it's not just the sponsors. It's every one of you is a vital part of this interconnected network of advanced manufacturing in Wisconsin. The MERC conference is all about networking and knowledge sharing. And the more we work together, the more we'll learn and grow. Which brings us really full circle in thinking about connectivity. And we have to connect people, processes, and technologies at every level. And today, connectivity is part of the fabric of everything we do. Together, we can help build a roadmap for the future of manufacturing for the state of Wisconsin. Of course, one of the resources that can help you develop and implement your own strategic roadmap is the Connected Systems Institute here at UWM. We understand that manufacturing businesses must fundamentally transform strategies and organizational culture in order to benefit from Industry 4.0 and the new AI-powered ecosystems it promises. The challenge is to embrace the Industrial IoT, which is really the quintessential connected systems. Companies that successfully transform today, connecting people, technology, and processes, will position themselves as more productive, more profitable market leaders in a great position to be able to address that 75 billion market opportunity available from this new age of digitization. At CSI, our goal is to create a forum for leaders in industry and academia to come together to share knowledge and skills and to provide an environment for collaborative research. We want you to benefit from advanced manufacturing facilities, such as the one that we're showing here, in addition to the collaborative relationships that you develop from the people that you're working with. From an academic perspective, we're working on development of workforce training and curriculum designed to ensure that we have well-trained, fully technology literate people to help manage our processes and technologies as our world evolves into the future. The CSI was founded in partnership with some very advanced technology partners, Rockwell Automation, Microsoft, Dell, Cisco, Fortinet. All of those tools are there and create a rich environment for research and collaboration and study. I want to close by thanking all of the partners and faculty who supported this conference. And also I want to thank you who are all working to turn these ideas into reality every day. As Thomas Edison, another visionary from another era of technological disruption, once said, the value of an idea lies in the using of it. So go out there and use it. I want to thank you all for joining me today and listening to my opening address. And I'd like to turn the program now back over to Dr. Wilkestar Otieno, Chair of the Industrial and Manufacturing Engineering School at the University of Wisconsin-Milwaukee campus. Dr. Otieno.